Okay, welcome back, student, to automotive class. Okay, at KU. Today we will talk about automatic transmissions. Okay, so automatic transmission is a type of transmission, right? As compared to manual transmissions. Okay, but the function is the same. Okay, it is to allow the engine to operate at its narrow range. Okay, while providing a wide range of output speed. This is the vehicle speed. Okay, so using a very narrow range of engine, okay, to provide a very large range of vehicle speed. Okay, now the key difference between manual and automatic is that, okay, normally for manual, okay, we have different sets of gears, right? We have first gear set, we have second gear set, okay, pair, okay, first gear pair, second gear pair, third gear and fourth gear pairs, right? Now, which speed that we want, okay, we're gonna connect that pair to the shaft, right? So we have different gear pairs, okay, to provide different gear ratio. And which one we want, we just connect that one to the shaft. Okay, that's manual transmissions. However, for automatic transmissions, okay, we use the same set of gear. Okay, one set of gear that can provide forward gear ratios. Okay, the forward with smaller gear ratio, it can provide reverse, it can provide neutral. Okay, one set of gear can provide many gear ratios. Okay, we can do that because we use planetary gear set. Okay, this is a type of gear set, the planetary gear set in automatic transmissions. Okay, so what for the driver point of view, okay, we only have P, R, N, D, okay, and the rest, right? So normally when we park our car and we want to prevent the car from moving, right? We shift into park. P is park, right? To reverse, okay, we shift into R. Okay, N is neutral. Gear 1, okay. D is drive. Okay, and we have a 3, 2, 1 like this, or 2L like this. Okay, when we say 3, when we shift into D, it means that the computer or the car shift gear for us, right? So it go from 1 to 2 to 3 to 4 to 5 to 4 to 3 to 4 to 5, okay, for us, okay, depending on the condition that we drive the car. Okay, if we shift into 3, it doesn't mean that we use third gear. Okay, it just say that the maximum that the gear can choose is third gear, so it can go from 1 to 3 to 1 to 3 like that. Okay, if we shift into 2, it means that the maximum is 2, so it shifts between 1 and 2, right? So 1 and L is just 1. Okay, so the component inside the automatic transmissions, okay, very different from manual transmissions. Okay, from the engines going to this gear trains going out the output shaft from transmissions. Okay, for manual transmissions, okay, here we have clutch, right? But for automatic transmissions, instead of clutch, we have a torque converter. Okay, so this takes place of the clutch. So clutch is used to disconnect and connect engine power, right? So the same thing, torque converter is used to connect and disconnect engine power automatically. Okay, not like clutch. Clutch we have to manually operate, right? But torque converter is manual. And then the powers go to the planetary gear. So this is different from the manual transmission that only have a gear set, okay, gear pairs. Now we have planetary gears here. Okay, for planetary gears, okay, because we have same set of gears, okay, in order to shift gear or change the gear ratio, okay, we have to be able to hold one gear and let another gear free and let input into another gear, okay, output to another gear. So we have to be able to control the gear inside the planetary gear. Okay, in order to do that, we need this apply device. Okay, apply device is the device that used to control the movement of the gear or the position. I could say the motion of the gear inside. Sometimes we have to stop the gear. Sometimes we have to connect one to the other one, right? So we control the connection and the motion of the gear using this applied device. And normally the applied device is controlled by hydraulic pressure. So we need pressure to control it. So then, therefore, we have hydraulic control to control the applied device. Okay, and now with the new technologies, with modern technologies, okay, the hydraulic control, the hydraulic system is controlled by valve. Okay, and modern system has electronic valve. Okay, a solenoid valve which is electronic. So we need computer control to control the valves, and the valves control the hydraulics. Okay, and that hydraulic control the pressure, and that pressures control the applied device, and then the applied device control the planetary gear set, and then we can shift the gear. Okay, so those are the components of automatic transmissions. Okay, this is a picture of automatic transmissions. You can see, okay, if you compare it to manual transmission, okay, it is totally different. This is a planetary gears, and you have all of this strange component in there, and you have this plate, okay, little plate, a lot of plate there. Okay, many things. Okay, even here, this is a picture of a torque converter. Okay, we used to see clutch, right? Clutch has 3 plates inside. Okay, torque converter is like a pump. Okay, it has an impeller inside. Okay, it has blade, it has impeller inside. So it's totally different operations. Now, so the operation of automatic transmission is that, okay, when you shift into drive, okay, automatic transmission engage first gear. Okay, however, the vehicle cannot move because we apply the brake. Okay, the driver applied the brake, and then therefore the car cannot move because it have very small power, and the brake overcome all of that power. So that's why the car doesn't move. Okay, until we lift off our brake pedal, okay, the car start moving, and when we accelerate, the car accelerates. So the speed increase. Now, when the speed increase to some point, automatic transmission shift to second gear for us, right? And then if it start increasing again, it shift to third and fourth and fifth gear. Okay, depending on our speed and our the driver behavior. Okay, so this happen automatically. Okay, the gear shift. Okay, depending on the vehicle speed and engine load, or the other word, the throttle opening. Okay, how much we open the throttle valve, actually how much we step on the accelerator pedal. Okay, so automatic transmission monitor 2 things. The first thing is vehicle speed. The other thing is the engine load or throttle positions. Okay, if you have a lot of throttle, it has to shift down. If you have a lot of speed, it has to shift up, like that. Okay, in case of slowing down and stop, okay, automatic transmission shift down for us. Okay, until you get first gear when the car stop. Okay. Now, the first component of the automatic transmission is the torque converter. Okay, this torque converter replaces the clutch, right, in manual transmissions. So the objective of the torque converter is to connect or disconnect engine power automatically. Okay, so the concept that it uses is that the torque converter uses the fluid coupling. So it sends power using fluid. Okay, that's a fluid coupling. Yeah, inside there is an impeller, there is a vane, there is a fluid inside, and we send power through fluid. Okay, this is a picture of torque converter. Okay, it is like a space inside. This is just a housing. Okay, it is big and heavy. Okay, it connects to this flex plate. Okay, which we can consider is as a flywheels. Right, it connects to the flywheel, and the flywheel connects to the engine shaft. Okay, so basically the torque converter okay, at least the housing, okay, rotating with the engine. It rotates with the engines all the time. Okay, now if we go into detail, okay, inside the torque converter, we use the concept of fluid coupling. Basically, fluid coupling has two components. One of them is impeller, or sometimes we can call pump. Pump used to convert mechanical energy into fluid energy, okay, fluid flow. Okay, and then this impeller will create a fluid flow, okay, and then that fluid will be sent to turbine. Okay, this turbine, okay, basically the turbine is something that convert fluid energy into mechanical energy. So we convert mechanical to fluid here, and then we transmit the power using fluid, and then we convert the fluid energy back to mechanical energy using a turbine. Okay, so this is a concept. Okay, just try to imagine that you put a fan, okay, a typical electric fan, and face them against each other, okay, and you turn on one of the fan, just like that. Okay, when you turn on the fan, okay, the wind, okay, flow out of the fan and reach another fan, which is off, right? And that fan start rotating. Okay, we send the power that way using fluid. Okay, but using air is not really efficient, right? Using the fluid or liquid is more efficient. Now, inside the torque converter have many components. Okay, the first one is torque converter housing, which is this one. Inside the torque converter housing, we have impeller and turbine. Okay, impeller is actually a part of housing. Housing and impeller is the same part. Okay, it attached to each other. Alright, so this is one of the impeller. It is the same part as a housing. We have a turbine, the other one. We have a stator, which is this little one. We have overrunning clutch, which is in the middle of the stator. And we have a lock-up system, which doesn't have it in this picture. Okay, see how we connect those components. Okay, from the flywheels. Okay, this is the flywheel from the engine, right? So basically, this is the engine. Okay, engine connect to the housing of the torque converter. And as I said, okay, the impeller is the same part as the housing. It is the same part. So this is a pump or impeller. So housing and impeller connect to the engine. So it's rotating with the engines. Okay, the other part is this turbine. Okay, the turbine is connected to this output shaft. Okay, the turbine output shaft, but it's connected to the transmission. So this shaft is basically transmission input shaft. Okay, this is the transmission input shaft. Okay, so this turbine connects to the transmission input shaft. Okay, and we have a stator in the middle. This stator is on another shaft. Okay, this shaft, we call it stator output shaft. Okay, it's connected to the fixed shaft. Basically, this is a fixed shaft. Okay, stator is on a fixed shaft, which is not this shaft, which is not this shaft, right? Another shaft like that. Okay, so this is a illustrator. Okay, so from the housing, it connects to the impeller. The turbine connect to this transmission shaft. Okay, and we have another fixed shaft which has a stator on it. Okay, between the stator and this fixed shaft, we have this one-way clutch or overrunning clutch. Now, so when torque converter operate, okay, we add a fluid inside the torque converter. Okay, when the impeller rotate with the engine. Okay, it will pump the fluid, okay, and send the fluid to the turbine. Okay, so after this rotate, okay, it will blow the fluid, okay, to the turbine like that, and the fluid will drive the turbine such that the turbine can start rotating. Okay, however, okay, when the speed of the turbine and impeller are different, okay, when it has large difference between in speed between the impeller and turbine. Okay, when the fluid flow through the turbine, it changes direction, right? So impeller send the fluid to the turbine. So when it go into the turbine, it drives the turbine and it come back another direction. It come back another directions, and these directions sometimes oppose the impeller. So impeller is rotating, and this one block the impeller, which is not good. Right? That's why at some situations we need this stator. We need the stator, okay, to change the direction of the fluid. Okay, so now the fluid coming out from the turbine, instead of opposing the impeller, so we reverse the flow and then make this flow assist the impeller. Okay, so we can see in this picture. Okay, normally, okay, the impeller operate, okay, it is driven by the engine, right? So when engine drive the impeller, okay, it create a flow of fluid, okay, and send it to the turbine. Okay, the fluid go into the turbine, and then it push the turbine. Therefore, the fluid has to change directions, okay, because we use momentum of the fluid. So the fluid change directions. When the fluid change directions, okay, the fluid that return from the turbine, it oppose the impeller. So it go into opposite direction of the impeller. So impeller is rotating, and this one block the impeller. Therefore, in this case, okay, we need this stator to reverse the flow. Okay, the stator then reverse the flow, such that the flow that coming out from the stator can be in the same direction as the impeller, just like this. Okay, so we get some kind of torque multiplication there. Okay. However, when the two parts, okay, the pump and the turbine having the same speed, okay, in this case, the fluid just go from there to the turbine and going out to the impeller. Okay, it will not, oppose the impeller. In this case, the fluid can just flow around, okay, and we don't need stator anymore. Therefore, in this case, we have to let the stator flow. We let this clutch unlock, okay, and the stator start moving. Okay, in this case, the stator have to fix, right? Have to be fixed, have to stay. Okay, so this is how the torque converter operate. Okay, that's why we need the stator. Okay, so this is the explanation what I talk about. Okay, so the stator has to be on a one-way clutch. Okay, sometimes stator is stationary. Sometimes the stator rotate with the turbine. Okay, so we have to have a one-way clutch. Okay, at the hub or at the center of the stator. Okay, let's say this is the stator. So we have a one-way clutch. So one-way clutch is allowing to operate or allowing to rotate in one way. So it cannot rotate back. It can only rotate in one way. So that's one-way clutch. Okay, you have a different design, the roller clutch or the spark clutch. Okay, now when it reaches the coupling phase, okay, when the torque converter reaches the coupling phase, so the two the impeller and turbine having the same speed. Okay, if we continue to use fluid to transmit power, the efficiency of transmission is not good. So there is a lot of loss because there is a lot of slip between the fluid and the vane, the vane of the impeller and turbine. So this difference in speed is slippage. Okay, which means that torque converter is not really efficient in transmitting power. Okay, but we need that. Okay, actually fluid coupling is not really efficient. Okay, but it is good because it can slip. Okay, when we want to disconnect engine to the drive wheel, okay, we will let the torque converter slip. So fluid just go there but do nothing. Okay, just flow in and out but do nothing. So we want that because we want it to be automatic. However, fluid coupling is not efficient. Therefore, whenever the two components reach the same speed, okay, we need another mechanical component, which is a lock-up system. Okay, lock-up system is this piston. Okay, they call this piston, which is like the whole plate. Okay, this is the whole plate. Is called piston. Okay, clutch piston. So we add this plate so that we can lock the two together. Okay, when the speed is close enough. Okay, so we have a piston here in the front. Here, right? We have a piston here in the front. Okay, this piston is connected to the turbine. Okay, so when the clutch lock, okay, the control system will send the fluid behind the piston, okay, the clutch piston, and then the piston is like pushed forward, okay, against the housing of the torque converter. Okay, so now when the piston is pushed against the housing of torque converter, the power is transmitted from the engine to the housing, and instead going to the impeller and the fluid, right? So it sends power directly to the turbine, and turbine connected to this shaft. So we send it using mechanical, how do you call it? Mechanical parts, okay? Mechanical parts from the torque converter housing into the transmission input shaft. Or in this case, we get higher efficiency, okay, sending power through mechanical connections, okay, having like 98% efficiency. Okay. Now, the power from the torque converter, okay, is sent to the gear, okay, the planetary gear. Okay, this is a picture of the planetary gears. Okay, planetary gears have many gears, okay, meshed together. The first one is the middle one. This middle one is called sun gear. Okay, the middle one is called sun gear. So you have the sun in the middle, just as a planet, right? And then from the sun, you have many planets. Okay, in this picture you have you have 4 planets. Okay, we call this planets. Okay, all the planets are connected together using this carrier. Okay, they call it planet pinion carrier. So this is a carrier, or this is a picture of it, right? So they connect together, okay, in one piece. Okay, there are many planet pinion, and combining with the carrier. So this is a planet pinion carrier, and then the pinion is matched with this, okay, internal gear. Okay, the internal gear, or sometimes we call ring gear or internal gear. So this is the component inside the planetary gear set. Okay, with this one set, the planetary set, okay, you can create 5 conditions. Okay, the first one is speed increase. Okay, this is like overdrive, just like 5th gear. Okay, we can also create speed decrease. Okay, so we reduce the speed. We can create direct drive. Okay, which is the same speed. Okay, in and out with the same speed. We can create reverse, and we can create neutral. So no power output from this gear. Okay, so then we can create like 5 conditions using one set of gear. That's good, right? That's why automatic transmission use planetary gears. Okay, how you do that? Okay, there are examples. Okay, so the way to do that is that, okay, we have internal gear, we have a carrier, we have sun gear. Okay, what we can do is that we can input into one component, we can hold another component stationary, and then we can output from another component. Okay, so we can connect input shaft to one component, we can connect output shaft to one component, and we can hold one component fixed or stationary. Okay, for example, okay, if we input to the carrier, okay, and we hold the sun gear, so we hold the sun gear fixed, right? We input at the carrier and then we output at the internal gear. So this is fixed. We pull this, okay, the carrier, and then we let this as an output. Okay, you can see that, okay, this is fixed, right? So when this rotates, okay, when the pinion rotates, okay, so this is fixed, right? This speed will be smaller than this speed. So the internal gear will be faster, having a faster speed, right? Therefore, what we get is I, which is the increased speed. Okay, so you can hold this, input there, and that get increasing speed. Okay, or you can hold this, input there, output there, you also get increasing speed. Okay, if you hold sun gear, input here, input here, right, and output there, you get lower speed. Okay, L is decreasing speed. Okay, you can decrease speed, you can decrease speed, you can reverse and increase speed, and you can reverse and decrease speed. Okay, just the combination whether you input there and output there and hold which one. Okay, further than that, okay, you can also create direct drive. Okay, direct drive is created when any two members are locked together. Okay, we have three members, right? The sun gear, the carrier, and the internal gear. Okay, if you lock any two together, these two, or these two, if you lock them together, you get direct drive. Okay, or you can create neutral, so no output power. Okay, when you want to create neutral, okay, it is created when no member of planetary gear set is held. Okay, just let everything free. Input any gear and let everything free. There is no output from this planetary gear. Okay, so you can do that by controlling this, holding one gear, input another gear, right? Output another gear using planetary gear set. Okay, I have some animation. Okay, let's see if I can open that. Just a second. Wrong file. Okay, let's see. Okay, in this picture we have a sun gear in the middle, we have the planet pinion, we have a ring gear, right? So if you want to get gear ratio of 3.4, okay, you hold the ring gear stationary, okay, and you output at planetary and input at sun gear. So first case, go. Okay, so in this picture or in this animation, you have to look okay, so you have to look at, this is the input, okay, the red dot. Okay, the output is the black dot, or you can see this brown pinion. Okay, this is the output. So comparing this to the dot, to this input dot, right, it is slower, right? So the brown is slower than the input. So we get reducing speed, right? So such as first gear, second gear. Okay, we get this reducing speed. Okay, if we want to get higher speed, so the gear ratio is 0.7 to 1, we do this. Okay, we can hold the sun gear stationary. Okay, input at the carrier, which is this guy. Okay, hope you can follow that. And the output is ring gear. Okay, you can see that the outer dot here is very fast, right? Faster than anyone else. So in this case, we get increasing speed. Okay, if you want to go reverse, okay, when you go reverse, you have to hold the middle one. Okay, normally you have to hold the planetary carrier or the planet carrier. So when you hold planet carrier, this one go right, the sun gear go right, the ring gear go left, like that. So you input to the sun gear and output to the ring gear. Okay, you got that? Okay, you can search in the internet, right? I got this from the internet. Okay, close. Now, that's the concept of planetary gear. However, in actual automatic transmission, it has more than one planetary gear set. It probably have two planetary gear set. Okay, there are different types. The first one is Simpson planetary gear set. Okay, it has two of anything, but it has a common sun gear. So sun gear is connect together, and they have like different pinion and different ring gear. Okay, this one is compound planetary gear set. It has only one internal gear, but it has two set of planet pinion and two set of sun gear. So to do that, okay, it is because we want more gear ratio. Okay, we want more gear ratio than just like two reducing gear ratio. We want more than that, so we have to add more planetary gear. But the concept or the operation is the same. We have to hold one, we have to input one, we have to output one. Okay, so now how do we hold the gear? How do we connect this shaft to this gear? How do we do that, right? So we have to use the apply device, okay? The apply device, which are, it can be a band, it can be a one-way clutch, it can be multiple disc clutch. Okay, this band is used to hold something stationary. Okay, one-way clutch is to prevent it from reverse. Okay, multiple disc clutch is used to hold one piece to another piece. Okay, just like that. Okay, this is a simple diagram. Okay, so this is a planetary gear. You see, this is a sun gear. Oops. Okay, this is a sun gear. This is a pinion, planet pinion. This is a ring gear. Okay, we cannot really hold the gear, but we can hold anything that attached to the gear. For example, this sun gear is attached to this drum. Okay, we have a drum attached to the sun gear, like that. The drum looks like this. Okay, this is a drum. This is the band. Okay, the band covers the drum like that. So if we want to hold sun gear, we can hold the drum. In order to hold the drum, we can squeeze this band around the drum, right? We can tighten the band around the drum. So what we do is that we have actuator operated by hydraulic. Okay, we send the pressure of fluid pressure there to this actuator. Okay, it moves this pin. Okay, they call it strut. They move the strut and the band. Okay, tighten on the drum. Okay, it squeeze the drum. Okay, that's it. Right. So now we can stop the sun gear. Okay, this is one component. Okay. The other component is multiple disc clutch. Okay, here if you go back to this picture, okay, we have this component, this shaft connect to the carrier. Okay, and then the carrier, okay, connect to this plate. Okay, you see this plate. Okay, and also this drum, okay, is attached to this plate. Okay, you see another plate. Okay, there is a plate actually installed. The plate installed on this carrier, another plate installed in the drum. Okay, the 3D picture is this guy. Okay, you see the drum. Okay, we have different clutch plate. Okay, this is clutch plates. Okay, each clutch has different design, right? This one has teeth on the outer side. This one has teeth in the inner side. Okay, inside. This is outside. This is inside. So we put this plate in the drum. So the white one will be rotating with the drum, right? And the orange one will be rotating with this cylinder, right? This cylinder. So to see the cylinder, this is a cylinder. Okay. So when we want to connect these two components together, okay, sun gear and the planet carrier. So what we do is that we send the fluid pressure, okay, behind this piston. Okay. So when the pressure push the piston, it pushed all the plate together. So when it push all the plate together, it means that sun gear will be locked to the carrier. Okay, we will lock sun gear to the carrier. Just do that. Okay, this is a piston. Piston looks like this. This is a piston. Okay, so this is another applied device. Okay, so here, this is a piston. Okay, we send the pressure here, okay, to push every plate together. Okay, when we push every plate together, this drum connect to this cylinder. They call it cylinder, but connect to the carrier and the drum, which means side gear connect to the carrier like that. Okay, so it is operated by hydraulic. Okay, which means that we need hydraulic in automatic transmissions. Okay, we have a kind of hydraulic system using fluid, okay, using liquid as a to send a command, okay, to control it. So we have hydraulic system. Okay, it has many jobs. Okay, the first job is to supply fluid to the torque converter. Okay, torque converter have fluid, right? And then it direct pressurized fluid to band servo, okay, to control the band and to control the multiple disc clutch, right? It also have a job of lubricating the part inside. It also remove heat. Okay, so it's not typical hydraulic system that only transmit power or only like control things. Okay, this hydraulic system lubricate also and remove heat also and control and transmit power also in torque converter. Okay, therefore we cannot use any just any hydraulic oil. Okay, we have to use special fluid, which is called ATF. Okay, the fluid is called ATF, which is automatic transmission fluid. It's not oil, it's a fluid. Okay, if it's oil, it just lubricate, right? But we not just lubricate, we control also. So we call it automatic transmission fluid. Now, because of this hydraulic system, okay, we need the component in the hydraulic system. Of course, we need pump, right? We need pump. Okay, we need some kind of pressure regulator. We need accumulator. We need piston. We need cylinder. We need all of this. The valve, right? That's hydraulic system. And the whole circuit of hydraulic system is like this in automatic transmission. Okay, you see the gear on the top. You see the clutch. You see the band, right? So we're gonna control those. Okay, using this liquid. So we have all this channel of liquid to flow in, or the pressure to apply. Okay, we have a pump here. We have all of this valve. These are the valve, a lot of valves. Okay, and we have some kind of sensor also. This is a whole hydraulic system in automatic transmission. Very complex indeed. Okay, so the ATF, okay, normally the color is red. Just add color. Okay, it do many things, right? It's transmit torque, it's coolant, it's lubricants, right? It's seal, it's transmit pressure, and anything, many things, right? So basically, oil. Okay, it is base oil plus a lot of additive, right? to control the foam, to control oxidation, to control viscosity, to control corrosions, okay, to clean parts, okay, to prevent, to protect the rubber part. Okay, now the transmission in each, okay, inside the transmission, inside the automatic transmissions, okay, many manufacturers have different design and they use different material inside. Therefore, okay, the fluid has to be compatible with the material inside the transmissions. Okay, which means that, okay, each manufacturers will have their own ATF, their own automatic transmission fluid. Okay, which is their own brands. Okay, for example, Mitsubishi have Mitsubishi ATF, Honda have Honda ATF, right? So that's for different manufacturer. However, there is a standard, okay, a standard between each manufacturers, okay, which is Dextron. Dextron is the center, okay, the center of the standard of ATF. Okay, anyhow, okay, if you can choose, okay, it is recommended that you choose the ATF from the manufacturer. Okay, I'm using Mitsubishi, so I'm gonna choose Mitsubishi ATF. Okay, because it is not just lubricant. Okay, it control the gear shift, right? So if you use wrong lubricant, wrong fluid, if you use wrong fluid that is not compatible, it means that your car cannot shift gear. Okay, the gear cannot shift. So that's a big problem. So try to use the original manufacturer fluid first. If you don't have that, you can use Dextron. Okay, there are Dextron 2, Dextron 3. Okay, that's the standard of ATF. Okay, here is the pump of the hydraulic system. Okay, the pump is a rotor pump. Okay, it has a plate like this because it has to send fluid to each channel. Okay, and this is a pump, and the pump is driven by this gear. Okay, and this gear is connected to the torque converter, and the torque converter is connected to the engine, right? So whenever engines runs, torque converter runs and the pumps run. So we always have hydraulic power as long as engine is running. Okay, so we got the fluid from under the transmissions. Under the transmission we have an oil pan. This is an ATF oil pan. Okay, we suck the fluid through the filter. Okay, we have the filter there. So the ATF go there through the filter, go to the pump. Okay, and the pump send the fluid to everywhere. Send the fluid to the torque converter, send the fluid to valves. Okay, here, inside there, okay, we have a valve body which has a lot of valve inside and a lot of channel inside. Okay, this valve body is on top, okay, on top of this filter. Okay, just under the gear, under the transmission, we have this valve body. Basically, the valve body is the brain of the automatic transmission. It controls everything. Here in valve body, it has valve. Okay, you see shift valve. Okay, shift valve between 1, 2, so between first gear and second gear. Okay, shift valve between 2, 3. Okay, 3 and 4, 2 shift gear, and there is also like 3 and 4 shift gear. Right? In Thai เราเรียกสมองเกียร์ Okay, so we call สมองเกียร์. Now, after the valve body, okay, we have a separator. This has a hose, okay, just to direct the fluid to the right direction or to the right channel. Okay, this is a separator. Okay, now, how do we control the shift? Okay, control the gear shift. Okay, the time or the sequence that we control the gear shift is called shift timing. Okay, whenever we want to shift, okay, it's shift timing. Shift timing depends on two things, okay, two factors. The first factor is vehicle speed. The other factor is engine load. Okay, engine load is related to the throttle position. Okay, how much you accelerate the car. Okay, that's engine load. So with these two factors, the shift valve operate. Okay, the hydraulic system. Okay, so this we have a shift valve. Okay, the shift valve is actually this guy. This is a shift valve. Okay, if we zoom in, okay, this is a shift valve. Okay, shift valve got fluid pressure from line pressure. This is the pressure from pump, so it has high pressure. So this one has pressure. Okay, and then that pressure is either go to the 3-2 shift, which is shift down, or going to 2-3 shift, which is shift up. Okay, this is shift down, this is shift up. The command for shift down, the command for shift up. Okay, if the valve is on the right, okay, if go to the right like this, we will shift down. If the valve is like move to the left, okay, we're gonna shift up. Okay, now the valve is moving left and right depending on the pressure on the right and the pressure on the left. Okay, pressure on the left is throttle pressure. So this pressure is related to the throttle valve. Okay, on the right, okay, it is called governor pressure. Governor pressure is a pressure that is related to the speed of the car. Okay, the vehicle speed. So now, if the speed is low, when we have high throttle, okay, of course the speed is low. Okay, the speed is low. The car has low speed, and we accelerate the car. Okay, we have to shift down because we want more torque, right? We want more force, more torque. So we have to shift down. So this shift valve command downshift from 3 to 2, like that. Now, if the speed increased, if speed has been increased, and we reduce the throttle of the engines, right? So now we have to shift up, right? So the shift valve command shift up like that. Okay, so the shift valve operate depending on the pressure on the two sides. Okay, how this pressure comes? Okay, the governor pressures come from this guy, which is called governor. Okay, this guy is called governor. Okay, the pressure that got from this guy is governor pressure. So basically, governor, okay, adjusts the pressure based on the speed, okay, the car speed. So how do you change pressure based on the speed? Okay, anything that change with speed, okay, must be centrifugal force. Okay, now for any rotating speed, okay, we're gonna use use centrifugal force. So basically, this governor use centrifugal force because it has a weight here. Okay, this is a weight. Okay, when it spin, the weight will move out because of the centrifugal force. Okay, when it spins slower, the weight will move in. So the weight will move out and move in. So when it move out and move in, it will push and pull this lever. Okay, and then this lever will be push the governor or push the valve. Yes, such that it create more pressure here. So now we get pressure depend on the speed. Okay, we have this pressure related to the speed. So this is a governor pressure, which is this one on the right. Okay, the blue one. Okay, the throttle pressure can be controlled by two things. Okay, the first one is can be controlled by the throttle linkage from the accelerator pedal. Okay, just get the linkage from that pedal to this valve. Okay, or we can use vacuum inside the intake manifold. This is vacuum from the intake manifold. Okay, intake manifold pressure, okay, is the representation of the engine load or engine, how much engine work, right? So we can use that also. Now, inside the hydraulic system also have accumulator, because when the valve shift, okay, when the shift valve open, Okay, if the fluid go too fast, okay, the shift, the gear shift, okay, will be very rough. It will be very quick. There is a shock of that. Okay, so we need this accumulator to soften the shift. Okay, to soften the shift. Okay, here, right? If there is a sudden engagement, okay, there will be a rough shift. Right? To get a smoother shift, we need accumulator. So it accumulates the fluid before it releases the fluid, right? So basically, it has a piston with the spring under there, right? You have a piston and we have a spring. So it accumulates fluid and it sends it out. We also have other valve inside automatic transmission. Okay, the manual valve is the one that user control. Okay, the one to detect which one driver want. Okay, the kick down valve. This kick down valve is operated by electronic. Okay, it is operated by this switch. This switch is connected to the pedal. Okay, when the driver step on the pedal and push it to the end, okay, just to the floor. When you put the pedal to the floor, this switch is on, and this switch will cause the throttle pressure to go to its highest point. Okay, the throttle pressure will go to the highest point. Okay, attempting, so it commands the downshift. So if we want to accelerate, so we want downshift, right? We want more torque. We want to shift down. So this kick valve do that. Okay, this kick down switch. So it's called kick valve. Now, automatic transmission is very hot. There is a lot of heat generated inside because of the torque converter. Where there is a lot of loss inside torque converter, so the fluid temperature increase fast. Therefore, we have to have a cooling. Okay, normally the automatic transmission is cool using some kind of heat exchanger. Okay, it is either in front of the radiator or inside the radiator. Okay, it can remove heat to the engine coolant, or it can remove heat to the air outside. Okay, you can see that. Okay, we have this ATF cooler inside the engine compartment. Okay, this is what happened. Okay, when you shift into P. Okay, when we shift into P, the park, right? So we only have this level when you shift to park. Okay, the one at the end, right? You will control. Okay, you will push this lever, okay, onto this parking gear. Okay, that stop the output shaft of the transmission from moving. Okay, it's lock the output shaft of the transmissions. Okay, just like that. Just have a lever to like prevent the shaft from moving. And now, because the mechanism is like that, it's not supposed, okay, to use for stopping the car. Okay, it's not stopping it. It's not prevent the car from moving. It just this P is just it just function to prevent output shaft from moving or output shaft from rotating. Right. So it's not supposed, okay, to use to hold the car. Okay, it's not supposed to use in place of emergency brake or parking brake. So if you park on a slope, okay, this P cannot help. It cannot guarantee that your car cannot move. Okay, you have to pull the parking brake lever. Okay, you have to pull the parking brake, okay, in order to prevent the car from moving. So if you park on incline, okay, you shift into P, and then you have to use the parking brake also, right? This is not, let's say, this is not guarantee that your car cannot move. Okay, it can get loose any time, right? And the car can move. Yeah. Now, with new technologies, okay, a lot of computer is getting very fast now. Electronic is getting cheap now. So nowadays, okay, the control of hydraulic inside the automatic transmission, okay, can use electronic now. Okay, instead of the shift valve that operate by the pressure, right? The shift valve operate by two pressure, right? Nowadays, instead of that, they use a solenoid valve instead. Okay, and what it does is that, okay, we get a signal from sensor. Okay, we get the engine load signal, we get the vehicle speed signal, sending it to ECU. The ECU command the solenoid valve. The solenoid valve open and close the shift valve. Okay, just to command the 2-3 shift, 3-2 shift, 3-4 shift. Okay, using electronic now. Okay, so it gets sensor like vehicle speed, engine load, and temperatures. Okay, so finally, there is another type of automatic transmission which is very popular now. Okay, for the new car in 2020, 2021. Okay, from 2020. Okay, it is very popular. It is called CVT. Stand for continuously variable transmission. Okay, continuously variable transmission, the CVT. Okay, how it continuously variable transmission. Okay, the typical transmission, whether it's manual or automatic transmission, okay, the gear ratio is fixed. Okay, the gear ratio is fixed. Okay, at one step it becomes changing in a step. Right, it go from 3.5 to 2.9. Okay, and then it go from 2.9 to 2.3. It go from 2.3 to 1.4. Okay, so it shift in a step. Okay, that typical automatic transmission, because the size of the gear inside the transmission is fixed, right? We cannot change the size of the gear, so the ratio is fixed. Okay, what problem is of the fixed ratio? Okay, when you have a fixed ratio, it means that, okay, when you want to increase the speed of the car, you have to increase the speed of the engines. Okay, so now if you fix the gear ratio, when you want to increase the speed of the car, your engine has to ramp up like this. This is the RPM of the engine, right? You have a RPM of the engines. Okay, RPM of the engine will ramp up. Okay, to increase the speed of the car, because everything is connected, right? So engine is connected to the drive wheel, right? So to increase the speed of the drive wheel, you have to increase the RPM. So first gear, the RPM increase, okay, from low to high, and then you shift to second gear, right? When you shift to second gear, you change the gear ratio. The engine speed become lower like this. Okay, however, vehicle speed is still the same because we shift the gear. So the RPM get lower like this, and then it ramp up again. Okay, to increase the speed, okay, you have to ramp up the engine speed, and then you shift gear, and then it ramp up again like this. Okay, what's the problem with this? The problem with this is that engine operate at the bad efficiency, okay, going to good efficiency and bad efficiency. Okay, so the engine operate at everywhere. Okay, so bad efficiency is bad, you still operate at that location, at that point, that position. So that's not really efficient in terms of fuel economy, in terms of energy efficiencies. Okay, so what CVT does is that CVT change the gear ratio continuously. Okay, let's say from 3.5, we go to 3.4, 0.3, 0.2, 0.1, 0.0, 2.9, 2.8, 2.7, 2.6. So it change continuously, have unlimited number of gear ratio. Because gear ratio can change, it means that engine doesn't have to ramp up. Okay, engine can operate at one point. Just stay there, engine just stay there, and then we change the gear ratios to change the speed of the car. Right, so the engine doesn't have to do this anymore, has to ramp up anymore. Just fix. It will be fixed at most efficient point. Engine will operate at the most efficient point, or the point that has most have maximum power. Okay, so that's a good thing of CVT. Okay, this allows engine to run at more constant speed, close to its maximum efficiency or maximum power, depending on what we want. right? So how do you do that? Okay, CVT, instead of sending power through gears, okay, instead of using gear, it used belt instead. This belt, the steel belt, okay, which is this guy. You see the belt? The belt is steel. Okay, if CVT is in a motorcycle, it will be rubber belt. But for cars, we have to transmit a lot of power, so therefore we need steel belt. Okay, we need steel belt. And steel is used with pulley, right? Okay, in CVT there is a two pulley, and pulley can move. Okay, pulley is separated into two parts, and this pulley can move in and out. Okay, when pulley move in and out, it changes the radius. Okay, it changes the radius. Okay, then pulley move in, the radius is large. When the pulley move out, the radius is small. Okay, so by controlling the pulley, the two sides of the pulley, okay, we can control the radius. And when we can control the radius, we can control the gear ratio. Okay, not gear anymore. We can control the speed ratio, right? We can change the speed ratio continuously. Okay, this is a CVT. It is very popular now. Okay, it used to be only for small car. Okay, because the strength of the belt is important. Okay, it cannot transmit a lot of power because we transmit using the belt. Okay, but now with new technology, the belt gets stronger and stronger, so we can put CVT in a more powerful car. Okay, such as like it used to be for the small size car, now it is used for full size car now. Okay, Toyota Altis use CVT. Okay, Nissan Tiana use CVT. Big car use CVT. Honda Accord use CVT. Right, so there are many models using CVT now. This is the next generation of the transmissions. Okay, however, we don't know yet whether it is strong enough, whether it's gonna last for like 10 years, 15 years, or 20 years. Right, just like the typical transmission is very, it lasts forever. Right, it doesn't fail, but CVT may fail. Right, we have to see. Okay, so that's it for the class. That's it for this session. Okay, about automatic transmissions. Okay, so thank you everyone for staying with me. Okay, and I don't know, see you again in the next class.